Hi, hello everyone. My name is Mariel Joy Di Bertolay and I'm from BSCESE 2B. For today's lesson, I am going to discuss all about minerals, including its definition and some of its properties such as crystallography, twinning, as well as the color and stripe. But bago tayong mag-discuss, ano nga ba ang kahalagahan ng pag-aaral ng minerals at ano ba yung connection nito sa geology? Well, madali lang ang sagot dyan dahil tayo ay nasa geology class, we are required to understand most geologic processes. But before we understand that, we must first learn about rocks. At bago nating pag-aralan ng rocks, syempre kailangan muna nating matutunan ang konsepto ng minerals dahil ang minerals ay ang component ng rocks. And with that, let me define minerals. According to this, minerals are naturally occurring compound or chemical element made of atoms arranged in an orderly, repetitive pattern. Its chemical composition is expressed with a chemical formula. Both chemical composition and atomic arrangement characterize a mineral and determine its physical properties. So mapapansin nyo dito, meron tayong list ng carbonate minerals. By the way, ang carbonate ay isa lang sa mga grupo ng minerals. Kasama niya ang silicates, oxides, sulfides, sulfates, may native elements din tayo dyan. Yung mga native elements natin ay from single element. Meron ding halides from halogen elements, phosphates at mineraloid. Balik tayo sa table. Meron ditong mineral at may corresponding chemical formulas. Madidistinguish natin ang chemical composition ng isang mineral kung titignan natin ang kanyang chemical formulas. Ang calcite ay may isang calcium, isang carbon at 3 oxygen. Pero kung mapapansin nyo, ang calcite, aragonite at vaterite ay may magkakaparehong chemical formula. Pero okay lang yon dahil ang nagdedetermine naman ng physical properties ng isang mineral ay ang kanyang chemical composition as well as yung kanyang atomic arrangement. At yung pagkakapareho ng chemical formulas between the three minerals ay tinatawag nating polymorphism between calcite, aragonite at vaterite. Bakit nga ba nangyayari yon? Although parehas ang kanilang chemical formula, but yung kanilang atoms naman are stacked in different configurations kaya nangyayari yon. Okay, let's move on. Sa susunod na slide, most minerals are formed by inorganic processes but some are produced by organic processes. Pag sinabi nating inorganic processes, ito yung mga minerals na nagmula sa mga materials that were not part of living things. Habang yung organic processes naman ay, ang pwede nating halimbawa dito, ang calcium carbonate na matatagpuan sa mga clamshells. All minerals are solid and occurs as crystals. Since ang chemistry ng bawat mineral ay different, ibig sabihin lang nun na no two mineral can produce the same crystal. Sa case ng calcite, aragonite at vaterite kanina, although parehas sila ng chemical composition, iba-iba pa rin ang mapaproduce nilang crystal. Living things can produce minerals. Ayun nga, yung sa calcium carbonate. At last dito ay ang mineraloids. Kung natatandaan nyo, itong mineraloids ay isa siya sa mga group of minerals. Ito yung mga few occurring substances lang. They also have a characteristic chemical composition. That's why minerals sila. But they are amorphous. Pag sinabi nating amorphous, yung atoms nila are not arranged in regular pattern. Meron tayong example mineral dito, ang mineral na opal. Ayan siya. Next one is occurrence and formation. So, saan ba nagmula? Saan natin matatagpuan ang mga minerals? Minerals form in geologic environments and thus under a wide range of chemical and physical conditions such as varying pressure and temperature. Yung mga minerals natin, pwede natin siyang matagpuan sa mga quarries, sa minahan, sa side of the mountain, sa mga stream beds, or even sa mga rocks. Nag-outcropping sila dun. or pwede silang mag-exist sa mga bato-bato. And we also have 4 main categories of mineral formation. Igneous or magmatic, sedimentary, metamorphic, and hydrothermal. Ang igneous or magmatic, in which minerals crystallize from a melt. Meron tayo dalawang example, ang biotite at diorite. Ang biotite ay isang extrusive igneous mineral. Ibig sabihin, natatagpuan siya sa mga bato na nag-erupt sa surface ng Earth. Habang yung diorite naman ay intrusive igneous mineral or yung nag-crystallize below Earth's surface. Second is sedimentary. Ito yung processes of weathering, erosion, and sedimentation. For recall lang, ang weathering is yung breaking apart of the decomposition of rocks. After ng weathering, mangyayari ang erosion kung saan mawo-worn away na yung mga decomposition of rocks and can be transported by wind or water. After nun, ang sedimentation naman ang mangyayari. Ito yung mga when eroded materials that is being transported by water settles out of the water column onto the surface as the water flows slows. Ang example natin dito ay ang aragonite from Sicily, Italy. So, ito yung itsura ng aragonite. Ayan. Next formation is the metamorphic, in which new minerals form at the expense of earlier ones owing to the effects of changing, usually increasing temperature or pressure or both on some existing rock type. Sa madaling explanation, ang metamorphic ay yung transformation lang ng isang bato by heat or by pressure or ng pareho. Ang example dito ay ang sapphirine blue is a rare high temperature aluminous mineral. Ito yung kulay blue. May mapapansin din kayong kulay white at red na nasa picture. Ito yung red garnet at saka yung quartz. Ayan siya. And last formation, meron din tayong hydrothermal. From the word thermal, ibig sabihin may kaugnayan sa heat, in which mineral are the result of the processes of weathering, erosion, and each which mineral are chemically precipitated from hot solutions within the earth. Ang example naman dito ay ang alpine fissure-type veins. Ito yung interesting kasi during deformation, yung incompetent rocks are literally squashed. Ibig sabihin nadudurog siya. Habang yung competent bends naman cannot accommodate that stress, kaya nagkakaroon ng fractures. At yung minerals na alpine fissure ay nagsisilbing infillings dito sa mga fractures na nabubuo. Kaya meron tayong ganyan. Ayan. Yung first 3 formation ay nagge-generally lead to varieties of rocks, habang yung hydrothermal naman solutions tend to follow the fracture zones in rocks that may provide open space, kagaya nga ng sa alpine fissure-type veins. For recall lang, meron tayong 4 main categories of mineral formation: igneous or magmatic, sedimentary, metamorphic, and hydrothermal. Ang last topic natin under ng introduction to minerals ay ang mineral structure. The structure of minerals is often characterized by the development of crystals. Mineral structure can be affected by temperature and pressure. Kagaya na lang ng diamond, because diamond develops under high temperature and high pressure conditions. Even so, malaking factor pa rin ang mineral chemistry para ma-determine natin ang structure ng isang mineral. Alright, so nasa second part na tayo ng ating discussion na kung saan pag-uusapan natin ng properties ng minerals. Some properties of minerals can be determined by inspecting the hand specimen, while yung ibang properties naman, kailangan pa natin gumamit ng mga sophisticated equipments. Ang una sa listahan ng properties natin ay crystallography. It is the study of regularity of form and internal structure of a mineral, such as the development of regular pattern of faces and angles between the faces. So yung tinutukoy nating face dito ay ang crystal face. It is the relatively flat surface by which a crystal is bounded. Next slide. When we talk about crystal, it is a solid body bounded by plain natural surfaces. We have here a crystal structure of halite mineral. Sa left side natin, or yung naka-label as A, ito yung buong view ng structure ng halite. And then yung B naman, ang partial part or yung expanded view ng unit cell. Mahalaga na matandaan natin that crystal is the three-dimensional repetition of some units of atoms or molecules. And then, meron din tayong crystallographic terms. Mahalaga na malaman natin yung mga terms na ginagamit dahil nag-aaral tayo ng crystallography. Meron tayo dyang morphological crystal, ang lattice, unit cell, at ang motif. Ang morphological crystal are finite crystallographic bodies with finite faces that are parallel to the lattice planes. While ang lattice naman natin, it is the atoms arrangement in a crystal. Ang unit cell, this is the pattern that yields the entire pattern when translated repeatedly without rotation in space. Ang last, which is ang motif or sa ibang book, tinatawag nating lattice point. It is the smallest representative unit. Pwede siyang maging atom or group of atoms. And para ma-visualize natin yung mga sinasabi ko, sa left image natin, meron tayong lattice point. Makikita nyo rin dyan ang unit cell at ang lattice. Ang unit cell ay pinagjo-join niya ang apat na lattice point. Each lattice point is being shared between by 4 unit cells. So malinaw tayo dun. Ang right image naman ay ang parameter ng ating unit cell. Ang ABC ay nagre-represent ng length, yung alpha, beta at gamma naman ang nagre-represent ng angles. Mahalagang matandaan natin ang parameter ng isang unit cell dahil pag pumunta tayo sa crystal structure, dito tayo magbe-base. So dapat tandaan natin ito. Ang next naman ay ang ating symmetry elements. Ang external shape or of a well-formed crystal expresses the Ang next naman ay ang ating symmetry elements. The external shape ng well-formed crystal expresses the presence or absence of a number of symmetry. Ang una nating symmetry element ay center of symmetry. Exists in a crystal if an imaginary line can be extended from any point on its surface through its center and a similar point present along the line equidistant from the center. For example, ang cube ay may center of symmetry. Makikita nyo dyan, meron tayong imaginary point na nasa center na kapag hinati mo ang plane along that imaginary line, equal pa rin ang distance ng dalawang side. Mapataas man o mapababa, kaliwa or kanan. Habang yung tetrahedron naman, malinaw na wala siyang axis of symmetry. Kapag sinundan mo yung dash line na yan, hindi equal ang distance niya from the center. Then, ang ating axis of symmetry or tinatawag siyang rotation axis sa ibang book. Ito yung imaginary line through a crystal such that a complete rotation of 360 degrees about it produces more than one identical view. Meron siyang 4 na klase, ang dyad, when the same view is seen twice or every 180 degrees. Ang triad axis, when the same view is seen thrice or every 120 degrees. Ang tetrad axis, when the same view is seen 4 times or every 90 degrees. At ang ating hexad axis, when the same view is seen 6 times or every 60 degrees. Meron tayong example dito sa baba. Ang unang figure natin ay ang hexagonal crystal. Kapag inalign mo siya in 60 degrees angle, makakabuo siya ng 6-fold axis. Dahil ang isang complete rotation na 360, kapag inover mo siya sa angle of rotation niya, which is yung 60, ang sagot ay 6. Pero dahil axis of symmetry, kailangan nating lagyan ng fold axis sa dulo, kaya magiging 6-fold axis. So, ganun din dito sa cube. na naka-align in 90 degrees, nag-create siya ng 4-fold axis, and so on and so forth. Ang huling symmetry element natin ay ang plane of symmetry or mirror plane sa ibang book. Ito ay nagdi-divide your crystal into halves, each of which is a mirror image of the other without rotation, and a crystal can have one or more symmetry. Kagaya na lang ng nasa example natin, nag-example din tayo ng cube ulit. The cube has 9 plane of symmetry. Yung symmetry plane natin is indicated by the thin colored plane. Ang cube natin ay may tatlong plane of symmetry that is parallel to the cube faces. Meron din siyang 6 diagonal planes are passing through the opposite cube edges. So kung tinignan nyo bawat isa, ang plane ay nagahati sa cube into similar halves dahil ayun ang plane of symmetry. Next one ay ang ating crystal shape. The key feature of crystal boundaries are such that A. The angles between them are determined only by the internal crystal structure. So sa 2 dimension, a plane lattice consists of an orderly array of points. The array is defined by the spacing between points and the direction or the angle between the points. Thus, the array can be reproduced by specifying the distance and angle to move from point to point. This is called translation symmetry. So kapag ang translation angle natin is equal to 90 degrees, ang array of points natin ay parang ganito. Paganyan siya. Pero kapag ang translation angle naman natin is not equal to 90 degrees, ang array of points natin maaaring maging ganito. Ang itsura, ganyan, paslant. So yun, tandaan nyo yun. B. The relative sizes of the crystal boundaries depend on the rate of growth of the crystal boundaries. The crystal shape of common minerals include isometric, tetragonal, hexagonal, orthorhombic, and monoclinic. Pag sinabi nating isometric or cubic system, has a unit cell in the shape of a cube, has 3 axes and most common and simplest shapes. Ang tetragonal naman has 3 axes that all meet at 90 degrees. C is longer than A and B, which are the same length. Mukha siyang rectangular prism, will have a square base and top, but its height is longer. Ang hexagonal has 4 crystallographic axes, consisting of 3 equilateral axes at 120 degrees to each other, as well as 1 vertical axis, which is perpendicular to the other 3. Ang orthorhombic naman, there are 3 axes, and all which of meet at 90 degrees to each other. However, all the axes are different length. And ang huli natin, ang monoclinic, all the axes are different length. 2 of them, A and C axis, meet at 90 degrees, but B does not. Next slide. Although crystal of a particular chemical and structural species tend to grow with a particular shape, the shape may vary but not the angles for some species. Meron tayong example dito ng ortholase feldspar. Ayan siya. Ang sunod na property ng minerals ay ang twinning, and twinning adds symmetry. During the growth of crystal, if it is subjected to stress or temperature or pressure, crystallization of 2 or more crystal of the same substance shows a symmetrical intergrowth. Ayun yung tinatawag nating twinned crystal. And twinning is important to recognize because kapag ito'y nangyari, ito ang most diagnostic features kapag nag-identify tayo ng minerals. And minerals such as orthoclase, marcroline, plagioclase, and calcite commonly occur as twinned crystals. And twinning is characterized by, una natin ang twin plane. Ito yung reflection across the lattice plane. Plane of symmetry that divides the 2 crystal into 2 symmetric parts. Ang twin axis naman, an axis which rotation is imagined to have occurred to produce the twin crystal. Ang twinning center is the inversion through a point. At ang panghuli, ang composition plane, surface along which the lattice point are shared in twin crystal, or ito yung 2 individual met along a plane. Twin law. Twin laws are expressed either from symbol to define twin planes or zone symbols to define the direction of twin axes. Kapag nagde-define tayo ng twin planes, gumagamit tayo ng curly braces. Pero kapag nagde-define naman ng twin axis, ginagamitan ito ng square bracket. Yung zone dito consists of a collection of a set of crystal faces that are parallel to a particular line or tinatawag nating zone axis. And remember that the twin plane is always parallel to a possible crystal face but never parallel to an existing plane of symmetry. We have two types of twinning. Ang una, contact twins. Ang pangalawa ay ang penetration twins. Ang mahalagang tandaan lang dito that contact twins have planar composition surface separating two individual crystal, habang ang penetration twins naman have an irregular composition surface separating two individual crystal. Nag-occur to if two or more parts of crystal appear to interpenetrate each other. So, yan siya. Ang example ng contact twins ay orthoclase twinned under Brabeno law with 021 as the twin plane. Ang example naman ng penetration twins ay ang orthoclase twinned under Brabeno law with 021 as the twin plane. Next slide. Contact twin can also occur as multiple twins. Ang una, polysynthetic twins, if the composition surface are parallel to one another. Ang example natin dito ay plagioclase. Is commonly shows this type of twinning called Albite twin law. Meron siyang 0-10 twin plane. Ang cyclical twins naman, if the composition surfaces is not parallel to one another. Ang example niya naman ay chrysoberyl na may 0-31 twin plane. We also have origin of twinning. Ang una nating origin ay ang growth twins. When accidents occur during crystal growth, and new crystal is added to the face of an already existing crystal, twinning can occur if the new crystal shares the lattice points on the face of the existing crystal, but has an orientation different from the original. Makikita natin dito ang twin plane or ang mirror plane at ang kanyang arrangement ng lattice points. Pangalawa, transformation twins. Occurs when pre-existing crystal undergoes a transformation due to a change in temperature or pressure. At ang panghuli, deformation twins. During deformation, atoms are pushed out of the place. If this happens to produce a symmetrical arrangement, it produces a deformation twins. So, ito siya. Ito ang before and then ang after. Last na topic na i-discuss ko under ng properties of minerals ay ang color and streak. So, streak palang basa dito, no? Hindi streak or strike. So, mali kasi ako ng basa kanina. Unahin natin ang color. Color is the most readily apparent property of a mineral because kapag in-inspect natin ang isang mineral, malalaman na agad natin kung anong kulay meron siya. But nakalagay din dito na slight impurities or defects within the crystal structure determine the color of many minerals. And color generally is a diagnostic for minerals with a metallic luster. Pag sinabi nating metallic luster, ito yung mga minerals na nagmumukhang metal, such as yung steel or copper. Dahil ang luster, ito yung appearance ng minerals when light is reflected from its surface. Meron tayong example dito ng 3 varieties of quartz. Ang amethyst na may purple color, ang rock crystal na may clear color, at ang smoky na may black color. So from this, masasabi natin na color is not reliable for identifying minerals dahil may mga minerals na maraming variation of color. Next one is ang streak. Streak is the color of mineral when finely powdered. It may or may not be the same color as the mineral. Streak is more helpful for identifying minerals with metallic luster dahil ang mga non-metallic luster natin have colorless or light-colored streak that is not very diagnostic. Paano nga ba natin ma-obtain ang streak? So, gagamit tayo ng streak plate. Ito yung unpolished piece of white porcelain. Kapag nirap natin ang mineral sa streak plate, dahil mas harder ang streak plate, ang mineral ay makakapag-produce ng powder. And when the excess powder is blown away, matitira na lang ang kanyang Streak. Because the streak of a mineral is usually the same color no matter what color of the mineral is, streak is commonly reliable than colors for identification. Ang example natin dito ay ang mineral na hematite. Meron siyang dark gray color, pero nung nirub siya or in-scratch siya sa streak plate, nagkaroon siya ng reddish-brown streak. Hindi tayo pwedeng mag-rely sa color kasi halimbawa, nakita natin na ang mineral ay dark gray, pwede nating masabi na magnetite siya or hematite. Kaya kapag mag-identify tayo ng minerals, mas reliable pa rin ang streak. Thank you for listening. Sana marami kayong natutunan. The rest of the properties will be explained by the next reporter. So please stand by as we speak. Sayonara!
Cleavage. Cleavage is the tendency of a mineral to break in definite direction along planes that are parallel to possible crystal faces. Cleavage is a reflection of the mineral's internal structure in terms of bond strength and distribution of atoms ions. This relation is particularly apparent in minerals that have layered structures in which the bonding within layers are very strong, whereas the between layers is relatively weak. Cleavage is a property of a mineral that shows the way of a mineral breaks, its breakage pattern. And this also talks about the internal structure, which is the strength and weakness of the mineral bond. And I can say na may kinalaman yung mismong structure nito sa kung paano siya nagbe-break. Kasi makikita natin sa example, say na yung red lines ay strong bonds and yung blue lines ay weak bonds. Kapag hinampas mo isang mineral, subukan mo siya i-break, unang masisira sa kanya itong mga weak bonds. Yan, yung color blue. At kapag nasira yung weak bonds na yan, nakita natin sa diretso siyang masisira, mapuputo yung bond nila, at magkakaroon siya ng smooth surface. Yun yung ibig sabihin ng cleavage. Example dito ay yung graphite at yung mica. Itong mica, family siya ng kung paano siya may cleavage property. Makikita dito yung mica, ito nipipil siya. Sobrang nipis nung pagka-break sa kanya. And ganyan yung property ng cleavage. Smooth na surface yung may iwan lagi pagka nag-break yung isang mineral. And next naman ay yung hardness. Hardness of a mineral is defined as the resistance of the mineral to scratching. It is a measure of the strength of the internal crystal structure of the mineral. Relative hardness has been employed as a useful diagnostic property ever since the beginning of systematic mineralogy. In 1824, it was given a qualitative precision by Frederick Mohs, who proposed a scaling for measuring a degree of hardness. Since then, mineral hardness is usually expressed in terms of Mohs scale as indicated in the table. So ito yung Mohs scale natin. Yung hardness na meron siyang level from 1 to 10. And then yung mineral, and then yung talc as the lowest and diamond as the highest. So, makita rin diamond siya pinakamataas. Ibig sabihin, walang ibang mineral ang pwedeng makapag-scratch sa diamond, kundi diamond. So, makikita natin dito, sa example na, ito yung picture na nasa baba, meron diyang mineral kung saan ni-scratch siya gamit ng isang fingernail. So, yung fingernail na yun, meron siyang level of hardness na 2.5. Kaya yung mineral na scratch ng fingernail, for sure, meron siyang level of hardness na below 2.5. At sa kaalaman na rin ng lahat, yung ni-scratch na mineral dito ay colonite at meron siyang 2 to 2.5 na level of hardness. Therefore, totoo na yung fingernail na scratch na tong mineral, sabihin, mas mababa yung level of hardness ng minerals sa level of hardness ng fingernail. Also take note then daw na the hardness given for mineral is that for a smooth, clean surface such as a crystal face or a cleavage plane. Therefore, superficial coatings of weathered or altered material may give susceptible low hardness values. Dahil nga alam natin yung cleavage, meron siyang part na merong weak bond at merong strong bond. So kadalasan pagka na-scratch mo yung weak bond niya, for sure masisira agad dun. At wag natin sa wag daw siya sana pwede siyang magmukhang mahina yung isang mineral dahil tinamaan yung weak structure. Siyempre, dapat i-stretch mo rin yung hard structure niya. At yun, next naman dun ay yung fine-grained masses of mineral may be disaggregated when checked for hardness, thus giving the false impression of having been scratched. In some cases, this false impression can be avoided by using the known as the scratch rather than the materials being scratched. Kumbaga, may mga mineral na mabilis siyang may part lang na parang biglang madudurog, ganun. At sinasabi dito na instead na siya yung i-scratch mo, gamitin mo yung mineral na yun pang-scratch sa ibang mineral. Kunyari, ni-scratch mo yung mineral na yun sa talc. Ni-scratch niya yung talc, therefore, mas mataas siya sa talc. At ni-scratch na masunod yung gypsum, sabihin, pagka ni-scratch niya yun, mas mataas siya sa gypsum. Ngayon na, pagka yung calcite ni-scratch niya at hindi niya ni-scratch yun, ibig mas mababa siya sa calcite para sa taas sa gypsum. So, below siya so, nasa between siya na 2 at level 3. Yun yun. And next naman natin ay yung luster. Luster, which is an optical property, is closely related to reflection and refraction. Luster is defined as the appearance of a material in reflected light. Minerals can be divided into two main categories on the basis of their luster, metallic and non-metallic. So luster daw is the mineral surface interaction with light. There is also submetallic. So yung submetallic yun yung imperfect metallic. Minerals with metallic luster are generally opaque, meaning they include most of their native metals, the sulfides and the metallic oxides chemically. On the other hand, minerals with non-metallic naman luster are generally transparent or translucent. So chemically, they include minerals of the other classes such as quartz or feldspar. So next natin ay yung varieties of non-metallic luster. So yan yung mga example niya. Vitreous, ito yung the luster of broken glass. It is a characteristic of minerals with refractive indices between 1.3 and 1.9. The range includes about 70% of all minerals comprising nearly all the silicates, most other oxysalts, the halides, oxides, and hydroxides of the lighter elements such as aluminum and magnesium. Magdadagdag dito yung vitreous sila para broken glass, ganun, para mga glass na translucent, transparent, at malaman natin na hindi niya gano'n na-reflect yung light kasi nga tumatagos ito sa kanya. Next naman ay adamantine. Ito naman yung parang brilliant luster typical of diamond. It is a characteristic of minerals with refractive index between 1.9 to 2 and 2.6. Examples are zircon. Example natin dito, ayan yung zircon. Nakikita nyo. Example natin dito ay yung zircon. Nakikita nyo dyan. Yan. So, malakas siya mag-refract ng light dahil nga dark colored siya at mas madali makita yung reflection ng light dito. So, naman ay yung resinous. Resinous naman ay yung mga parang resin from the word itself tsaka color ng amber. Ito yung mga parang nasa digta nung panahon kung saan natatrap yung mga bugs noon panahon, yung mga resin na itsura. So makita yung mineral na yan, para may resin-like siya na figure, yung mga amber. Next naman is silky. Silky, the appearance often termed sheen, which is typical of fibrous materials. Yan naman yung parang silky. Next natin ay pearlate, the semi-glossy luster of the inside of an oyster shell, a luster that is common on cleavage surfaces of some minerals such as the feldspar. Nakita natin siyang pearly, makikita mo para sa mga nasa loob ng, yung makikita mo sa mga shell ng oyster, kasi maputi na yung mismong loob niya dahil sa marami siyang parang, hindi mo siya pambasag pero yun nga luster niya. Yung mismong composition na structure niya, parang basag-basag na sa loob. Kaya pag tingnan mo siya, mukha siyang malabo na. Ganun. So, yung next naman natin, yung last natin ay dull or earthy. Dull or earthy, yan naman yung mga merong mga low reflectance ng light. Dahil nga sobrang na sila, parang dirt na, malupa na. Kaya pagka di na nila kaya i-reflect yung light. So, next naman natin, correlation of luster with bond type, refractive index, and light absorption. So may kinalaman din yung bond type niya sa kung gaano lakas yung refractive index, light absorption, and luster niya. Sa metallic, makikita natin na mataas siya sa lahat ng category, while yung covalent naman, moderately low at moderate, while yung ionic bond naman, lahat siya ay mababa dun sa refractive index, light absorption, at luster. So this table shows that luster can also be correlated roughly with color and light transmission. Metallic can be determined by minerals that have dark colored streaks and or are opaque. On the other hand, non-metallic are minerals that have white or light colored streaks and are transparent. So next naman natin ay yung crystal habit. Crystal habit naman define the shapes of commonly occurring crystals and or aggregates of crystalline grains. So crystal habit is a group of minerals' external form or shape. It is also about how well developed the minerals are. There are various terms that are used to describe crystal habits. So meron daw na mga example ay mga terms na ginagamit para ma-describe mo yung mga crystal habit ng isang mineral. So meron tayo itong acicular, yung mga parang needle or thorn-like shape, thorn-like form. So meron din tayong micaceous. Micaceous naman sila yung thin plate-like lamellae. Yun nga, dahil nga mica, yun yung mga maninipis na shards ng yung may cleavage na maninipis mismo ng mineral, maninipis na klase ng mineral. Tabular naman, table-like shape. And next is fibrous, like asbestos. Coliform, ito yung habit said to be radiating and in some cases concentric. The external spheroidal form resemble bunches of grapes or kidney, etc. Dendritic naman, branching like deciduous tree. Ito na may mga nagbabranch na parang puno. Cryptocrystalline, dense, in some cases almost glassy because it is made up of submicroscopic grains. Ito yung parang clear na siya na yun niya, parang glassy nature niya. Oolitic naman, consisting of small ellipsoids or spheroids that resembles fish roe. At yung medyo may spear na pabilog or ellipse na shape. Striations naman, parallel, thread-like lines or narrow bands running across mineral surfaces. Ilan naman yun? Mga crystal habit ng mineral. At specific gravity, this one's very interesting for me. Kasi the specific gravity of a crystalline substance is a fundamental property and thus characteristic of a substance. As such, it is a valuable diagnostic property. Specific gravity is a dimensionless number that can be defined as the ratio of the density of the material to the density of water. The specific gravity of a substance is primarily dependent on its chemical composition and crystal structure. So dito naman, ma-explain ko na yung minerals, they have their own specific gravity. At yung specific gravity na yun, yun yung para ma-determine mo kung anong klaseng mineral ba sila. For example, yung quartz, meron siyang 2.65 na specific gravity. Tapos ma-identify natin yung specific gravity ng isang mineral kapag kinuha mo yung dry weight niya at dinivide mo sa wet weight. Dry weight yung timbang na mismong mineral, siya lang mismo, yung mineral lang mismo. At yung wet weight naman ay nakalubog sa tubig pero hindi tumatama sa bottom ng container ng water at sa sides. Kumbaga nakasuspend lang siya sa mismong mid water. So makita dito na upon getting the specific gravity, there is a standard value for each mineral that you can search online. And there you can proceed to compare and identify with the value given. Example, you're wondering whether the mineral that you have is either quartz or topaz. So ngayon, titingnan natin dito para malaman mo siya kung topaz ba siya or quartz. Sa step 1, i-weigh mo muna siya gamit ng weighing scale. Siya lang mismo, yung mismong mineral lang. And then, i-list mo lang yung weigh niya. And then, suspend mo na siya in water. Kasi hindi tumatama, dapat hindi siya tumatama sa bottom ng container at sa sides. Kailangan nasa mid lang siya. At then, kunin mo rin yung weight nun. At pagkatapos nun, i-divide mo na yung dry weight sa wet weight. Ngayon, yung dry weight natin meron tayong 12.6 at yung wet weight ay 4.8. So pagka dinivide mo sila, magkakaroon ka ng 2.625. Ngayon, sa search mo online kung ano yung specific gravity ng quartz sa topaz. Makikita dito na yung quartz ay meron siyang 2.65 na specific gravity. Therefore, mas malapit yung 2.625. Kaya malaman mo na yung hawak mong mineral ay quartz, hindi topaz. So, in other words, the specific gravity of a substance can be said to correlate to its chemistry and its crystallography, and thus reflects the nature of the atoms in the structure and the manner of which they are packed. It may not be precise as given in the chart, pero meron kasi mga factors din na nakaapekto kung bakit nag-iiba yung mismong weight o yung mismong pagkakasolve mo, dahil pwede yung sa temperature ng water at meron din yung expansion ng mineral. So ayun, may mga factors na nakaapekto doon. However, this proves that each mineral has their own specific gravity.
For the continuation of the topic about physical properties, good day. I am May Adra, and today let's talk about tenacity and the degree of transparency. Let's jump right into it. So, the first topic is tenacity. So, by definition, tenacity refers to the toughness of minerals and describes its resistance to breaking and deformation. So, kapag ang minerals daw ay naglalaman ng kaunting tenacity, it breaks, bends, or deform easily. Kapag naman naglalaman ito ng mataas ng bilang ng tenacity, ang minerals ay matigas o unbreakable kung tawagin. Here, I will show you 6 terms used to describe a tenacity. So, the first term is brittle or brittle minerals. By definition, it is easily broken or powdered. It shatters into small pieces. Ito yung mga minerals na madaling basagin o i-crush into powdered form. Ang mga example nito ay highlight and quartz na makikita nyo sa picture sa presentation. So, the next one is malleable minerals. By definition, capable of being hammered into different shapes or into thin sheets. Ito naman yung mga minerals na madaling ihulma sa iba't ibang shapes, kagaya ng gold na ginagawang palamuti sa katawan at ang copper naman sa electrical components. So, the third one is sectile minerals. Sectile minerals are capable of being cut into shavings with a knife. Ito yung mga minerals na madaling hatiin o nahati kagaya ng gypsum. Ductile minerals naman, by definition, capable of being drawn into a wire-like shape kagaya ng copper na ginagamit sa electrical wirings. Next is flexible minerals. Capable of being bent into a different shape, but will not resume its original shape when pressure is released. Ang flexible minerals naman ay ang mga minerals na maaaring mabend sa ibang hugis ngunit hindi na maibabalik pa sa original form nito, kagaya ng chlorite and talc. Ang kabaliktaran naman nito ay si elastic minerals. Bendable without breaking, and it returns to its original shape after release. Kabaliktaran nito ng flexible minerals, si elastic minerals maaaring mabend ang mga ito, at ito ay babalik muli sa original na itsura o hugis nito. Upang mas maintindihan, I will repeat the 6 terms describing tenacity and its definition. The first one is brittle, easily broken o madaling masira. Malleable, can be hammered into different shapes. Sectile, can be cut with a knife. Ductile, can be shaped into wire-like shape. Flexible, bendable but can go back into original form. And the last one is elastic, bendable and returns to original shape. Now we are finished to tenacity. Let's proceed to the next topic, which is degree of transparency. So the degree of transparency, by definition, diaphanous or diaphaneity or degree of transparency refers to the ability of a mineral to transmit light and different interaction of mineral to light. There are three terms for identifying minerals according to its degree. So the first one is opaque minerals. It is a mineral that blocks light from transmitting through the surface or the mineral itself. Sa madaling salita, ito yung mga minerals where light can pass through or hanggang sa surface lamang ng mineral. Minerals can be opaque for the following reasons. So the first one is weathered surface or meron itong weathered surface na nag-i-scatter or nagbablock ng light. Pwede rin namang meron itong thicker sample or darker color. Pwede rin meron tong metallic element in which it reflects all the light at the surface. So the second degree is translucent minerals. This allows some light to enter the mineral's interior, but the light does not pass through it. Ang mga minerals na translucent ay nagtatransmit ng light, ngunit hanggang sa loob lamang o interior ng mineral at hindi na maaari pang tumagos hanggang sa kabilang side. The minerals may appear cloudy for the following reasons. Pwede itong dahilan ng inclusions of external materials as the crystal grows o yung kagaya ng dust na dumidikit sa crystal habang lumalaki ito. Pangalawa, pwede ring dahilan is flaws in the crystal lattice o yung arrangement ng atom sa isang crystal. So the third one is a mineral composed of various crystals positioned in different directions. So the third degree is transparency minerals. Light passes freely through clear minerals. Ito na yung mga minerals na nag-aalaw na tumagos yung ilaw hanggang sa kabilang side. So, sa presentation, makikita nyo yung tatlong pictures. The first one and the last one, it is a transparency minerals and the second one is a translucent minerals. Ang opaque, ang example ng mga opaque, yan yung parang mga pebbles, mga bato. Yan, yung mga darker color. So, yun yung example ng opaque minerals. And that's all the properties for us to easily observe and identify our minerals. But did you know, besides physical properties, there are other ways to help us identify or distinguish certain minerals from the rest? It is through special properties. Before we start, let us know what is special properties. In contrast to well-known physical properties, special properties may not be distinctive to most minerals, but it is certain that it can provide us with valuable information to identify a certain mineral possessing one of those unique features. Let's proceed to magnetism. Magnetism, some minerals such as magnetite, a strongly magnetic mineral, are attracted to magnets and can be put to magnetism tests. Para matest kung ito ba ay magnetic kagaya ng magnetite, simply put the magnet and mineral together to see kung ito ba ay magkakaroon ng reaction or not. The example of magnetite can be seen in the presentation. Take a look. So the next one is taste, odor, and feel. Some mineral contains a particular odor, taste, and feel. Ang highlight ay lasang asin. Ang sulfide minerals like zinc sulfide and sphalerite ay amoy rotten egg. At ang talc ay may madulas na sensation kapag hinahawakan. Again, yung mga pictures makikita sa presentation. So the last one is reaction with acid. The acid tests, or minerals reacting to acid, can be a guide to determine what kind of mineral it is. Carbonate minerals are reactive or responsive to acids such as calcite and dolomite. So, paano natin matetest ang minerals kung may reaction ba ito sa acid? Simply put or place a drop of dilute hydrochloric acid sa bato sa mineral. Makikita natin na maglalabas ito ng bula or tinatawag na effervescence or fizz for simple term kung ang mineral ay nagre-react sa acid. Dropping an acid to dolomite causes a slower reaction and strong fizz because nagko-compose ito mostly ng calcite. On the other hand, calcite easily effervesces or madaling nag-fizz. Some minerals can react differently towards acids such as dolstone, which has a very weak fizz reaction. Bakit nagkakaroon ng bula o fizz ang mga bato kapag nagkakaroon ng reaction sa acid? Dahil ito sa carbon dioxide gas na nagre-release sa materials. Kapag ganito ang nangyayari, posibleng it is a sign na mayroong presence of carbonate minerals sa material na ito. However, practicing this test can be possibly harmful to us without proper handling of the acid. So, be careful. So, makikita natin sa picture, ang reaction ng calcite sa acid, makikita natin na madali siyang bumula or reactive. And dolomite, makikita natin na strong yung reaction niya, pero slower than the calcite. And that's the end of the discussion about the topic properties of minerals. It's been a pleasure to be able to present this before you all. I hope you guys have understood and learned from us. Again, we are Group 1. Thank you and God bless.
Ayun na nga. Pagkatapos mag-discuss ang mineral structure at ang kanyang mga properties, lumako naman tayo sa topic na silicate minerals. Of the 100 or so elements known, only 8 are abundant at the Earth's surface. Is in decreasing order of abundance are oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. The common rock-forming minerals are formed mainly of combinations of these important elements, and most of them are silicates. Sa madaling salita, siya ang pinaka-common na uri ng mineral sa lahat. Kabilang dito ay ang quartz, feldspar, mica, ang pebble, na i-discuss ng umaya ng mga group nito. Olivine, pyroxene, and etc. na i-discuss mo naman. Nakapalob din dito ang dark-colored silicate minerals. It ranges daw from victor to dull in luster. Their other properties observable in all specimens. Yan, nakalagay dito sa table. And each of the important minerals in this group is now discussed. Napakita dito sa table na to yung na-observe daw in mga specimens, yung mga properties of minerals. May 5 mentionable na dark-colored silicate minerals. Ito ay ang mga olivine, pyroxene, hornblende, biotite, and garnet. Si pyroxene and hornblende ay parehas black, pero si pyroxene ay pwede siyang mag-iba. Pwede siyang maging brown. Katulad ni biotite. Si olivine naman ay green, si garnet ay pula. Babari ang kanyang kulay sa pagkapula niya. Specific gravity niya is 3.5 plus. Parehas, si olivine garnet, sila pinakamabigat. Magkano si biotite ang pinakamabigat. It is only 3. Si biotite na rin ang pinakamalambot, which is only 2.5. Magkano si garnet ang pinakamatigas. Malamang niya pati olivine. Sa cleavages naman, parehas si olivine at garnet with no cleavages. Parehas naman si pyroxene at hornblende with 2 cleavages. Tao lang si biotite with 1 perfect cleavage. Okay, next na i-discuss natin ay yung pangunang dark-colored silicate mineral. So ay ang olivine. It is the composition of magnesium, iron, silicate, and oxygen. It's a mineral formed at high temperature, which crystallizes early from a basic magma to form well-shaped, rugged crustaceans in most of the rocks in which present. Some crystals in igneous rocks may show corroded crystal faces. nakalagay dyan na picture dyan. May watak-watak na ano, or parang butas-butas na. Actually, ito ay olivine in basal. May iba pang klase ng olivine na hindi na ilagay dito. Yun ay ang Lunite Gabro Diabase and Peridotite. Many people are also familiar with olivine because it is a mineral of a very popular green gemstone known as peridot. Ito na rin nailagay dito sa slide nito. Some corroded crystal pieces because of a reaction with the surrounding magma before solidification was complete. Magma is hot liquid rock which, when consolidated, is known as igneous. Ayan. Makikita sa table kanina, yung color niya ay green or dark green. Ito lang yung usahin verde sa kanila. Next, pyroxene. Where X may be calcium, iron, or magnesium, and Y is silicon or aluminum. It exists in many varieties, but the most important one in igneous rock is the mineral rhodite. So, sa mga na-mention na sample ng pyroxene. The properties of which are listed in the table. Yan, kaninang slide kanina. The atomic structure of rhodite consists of single chains of tetrahedra and linked laterally by calcium, magnesium, and iron. The bonds between individual chains are relatively weak, and the cleavage directions are parallel to the chain. Rhodite has two cleavages parallel to the length of the mineral. Nakalagay na sa table doon. May dalawa nga daw siya cleavages, which are seen to intersect at about 90 degrees from the basal face of its crystal. Rhodite is also common in igneous rocks, which have a relatively low percentage of silica. Tatandaan, ito rin yung pinakamababang percent ng silica, and frequently occurs with olivine. No hydroxyl group is present in either rhodite or olivine, and both can be described as dry minerals. These minerals are rarely found in sediments since they alter easily when exposed to water and air. They may be present in some metamorphic rocks. May iba pang example ng pyroxene na hindi nailagay dito. Yun ay ang diopside, jadite, and spodumene. Rhodite. They are four of the best known members of the pyroxene group. However, the pyroxene group has many other members. Hindi na nailagay dito. Kagaya ni olivine, they also form under conditions of high temperature or high pressure. Next slide. Number 3, hornblende. A common where X may be calcium or sodium, Y may be magnesium or iron, and Z may be silicon or aluminum. It belongs to the Pebble group of minerals, and its main physical properties are shown in the table ng kaninang slide. Its structure resembles that of rhodite, and it has also two cleavages parallel to its length, which are seen to intersect at about 124 degrees on the basal face of its crystal. This angle of cleavage intersection is the most certain way of distinguishing hornblende from rhodite in a hand specimen. Hornblende is a common mineral in igneous rock with average amounts of silica. It crystallizes from magma containing appreciable amounts of water and can be said to a wet mineral since it contains hydroxyl group in structure. Kanina si pyroxene, di ba, walang hydroxyl group. Siya naman contain. Pinakaiba rin nila, si hornblende ay may average amount of silica. Si pyroxene naman ay wala or mababa. It is not very stable also when weathered at the Earth's surface and is rarely found in sediments. It is, however, a common constituent of metamorphic rocks. Next, the biotite. A dark-colored member of the mica group of minerals. Biotite usually crystallizes from a magma containing water. At the late stage in solidification, It is common in igneous rocks which are relatively rich in silica. No? Dahil pa lang sa ng presentation yan. Diyan mo malalaman yung pagkakaiba nila. Relatively rich in silica and also in sediments and metamorphic rocks. So, gaya dito yung nakalagay sa picture nito. Ito lang yung na-search ko na black ito. Pero ang nakalagay dito sa table ay brown siya. Yes. It's a dark colored member though, of the mica group. Its main properties are listed also in the table. Like all micas, the atomic structure of biotite consists of a sandwich with two sheets of linked silicon oxygen tetrahedra forming the outer layers. These are linked together by another layer of metallic cations. Magnesium 2 plus, iron 2 plus, iron 3 plus, and etc. And hydroxyl groups also. Each of these sandwich units is linked to another identical unit by a layer of potassium cations. The links are weak bonds in the mineral slips easily into place along the planes, separating the sandwich units. Biotite usually crystallizes from a magma containing water at a late stage solidification. It is common in igneous rocks, which are relatively rich in silica. Biotite is mined for use as an insulating material, yung pagkagamit mo, in certain electrical appliances from deposits where the crystals are about 1 meter across. Last but not the least, the garnet, where R2 plus may be ferrous, iron, magnesium, calcium, and manganese, and R3 plus may be ferric, iron, aluminum, or chromium, has a distribution restricted largely to metamorphic rocks. The most useful criteria to identify its enhanced specimen are its lack of cleavage and its hardness. Yung nakalagay kanina, di ba? None siya. Yung ito nakalagay sa table kanina. Garnet, non-cleavage. Hardness nga 7. Specific gravity nga 3.5. Which exceeds that of quartz, making it a useful, high-quality abrasive in such applications as garnet sandpaper. Madalas siya napapagkamalan na or mas pinaklasify siya as gemstone dahil sa hugis kaysa sa mineral. Most people think that garnet is a red gemstone. However, garnet offers in a wide variety of colors.
At this point, let's talk about light-colored silicate minerals, which is one of the classification of the silicate minerals. Good day, I'm Shalomel Barbacena. Let me introduce to you the silicate minerals and its properties. What is silicate minerals? Silicate minerals are the most important class because they are by far the most abundant rock-forming minerals. Here's the illustration of the structure of silicate tetrahedron. It consists of 4 oxygen and a silicon. The more silica, the more covalent bonding and the greater the stability to chemical weathering. The more cations and the ionic bonding, the lower the weathering stability, which means that the greater the amount of silica, the greater its stability to weathering. The silicate minerals have 2 classifications, the dark-colored silicate minerals and the light-colored silicate minerals. I will be sharing or discuss information about the light-colored silicate minerals. Mineral color indicates the specific gravity of the minerals. Minerals that are lighter in color are also lighter in weight. Darker minerals typically contain more of heavy elements like iron, magnesium, and calcium. So what is light-colored silicate minerals? Light-colored silicate minerals are made up of 70% silica. The light silicates do not contain heavy elements such as iron, magnesium, and calcium, rather contains varying amounts of aluminum, potassium, and sodium. Feldspar quartz and muscovite are one of the rock-forming minerals that can be classified as light-colored silicate minerals. Let's first talk about feldspar. Feldspar are a group of rock-forming aluminum textosilicate minerals containing sodium, calcium, potassium, or barium. Feldspar make up about 60% of the Earth's crust and 41% of the Earth's continental crust by weight. Feldspar crystallize from magma as both intrusive and extrusive igneous rock. Extrusive rock are formed on the surface of the Earth from lava, which called magma. Intrusive rocks are from magma that cools and solidifies within the crust. Feldspar can also be found in many types of metamorphic rocks as well as in sedimentary rocks. Let us now move to the major elements of feldspar: the potassium feldspar, the albite end member, and the anorthite end member. The first one is potassium feldspar that has potassium, aluminum, 3 silicon, and 8 oxygen. Potassium feldspar, also known as orthofeldspar. The name is from the ancient Greek for straight fracture because its two cleavage planes are at the right angles to each other. Orthoclase is one of the 10 defining minerals of the Mohs scale of mineral hardness, on which it is listed as having a hardness of 6. Orthoclase feldspar can be used in many ways. Orthoclase is a common raw material for the manufacture of some glasses and some ceramics, such as porcelain, and as a constituent of scoring powder. The gem known as moonstone is mainly composed of K-spar. Most moonstone are translucent and white and are used to make jewelry. The second element is albite end member that contains sodium, aluminum, 3 silicon, and 8 oxygen. Albite end member is a plagioclase feldspar mineral. It is a sodium end member of the plagioclase solid solution series. Albus is the Latin name of albite. Some properties of albite are: it is usually pure white. Based from Mohs scale of hardness, albite scaled by 6 to 6.5 of hardness. Albite melts at 1100 to 1120 degrees Celsius or 2010 to 2050 degrees Fahrenheit. Albite has two variants: the low albite and the high albite. Low albite is stable below approximately 70 degrees Celsius. High albite can be produced from low albite by heating above 750 degrees Celsius. It can also be found in meteor impact crater. Albite end member can be used as gemstone. It is used for ornamental stone as well as a component of ceramic clays and for mineral specimen. Potassium can replace the sodium characteristic in albite at up to 10%. When this exceeded, the mineral is then considered to be anorthoclase. Albite was first reported in 1815 in Finnbofalun, Darland, Sweden. Anorthite end member is the last major elements of feldspar that contains calcium, 2 aluminum, 2 silicon, and 8 oxygen. Anorthite is the calcium-rich end member of plagioclase feldspar mineral series. Anorthite is found in mafic igneous rocks. Anorthite is rare on Earth but is common on the Moon due to its high weathering potential in Goldich dissolution series. Anorthite melts at 1553 degrees Celsius or 2827 degrees Fahrenheit. It is brittle and translucent. Mohs scale hardness is 6. There are 4 compositions of feldspar: alkali feldspar, ammonium feldspar, barium feldspar, and plagioclase feldspar. Let's now move to quartz with elements of silicon O2. Quartz is a rock-forming minerals, is one of the most abundant minerals in the crust of the Earth, and is common in soils, rocks, and even atmospheric dust. It is hard and tough, so it survives on Earth's surface. Quartz is the second most commonly found mineral on Earth. Here are the properties of quartz. Trigonal, colorless or white, but occurs on almost every color like gray, purple, yellow, brown, black, green, pink, and red. Quartz is transparent to translucent. It has a white streak. It is commonly prismatic and can be massive or granular. It is called prismatic because of its unique and very identifiable crystal point. When a quartz is prismatic, it is usually valuable quartz. Hardness based on Mohs scale is 7. It cannot be scratched with knife. It is conchoidal fracture, it is vitreous, and it is piezoelectric and pyroelectric. Quartz crystal have piezoelectric properties that they develop an electric potential by applying mechanical pressure. Here are the varieties of quartz. Crystals of colorless or rock crystal quartz, the purple quartz, also known as amethyst, and the smoky quartz are common in rock shop but not in backyard. Milk quartz, rose quartz, and smoky quartz are quartz crystals that are common in many areas. Microcrystalline quartz like agate and onyx is defined as extremely fine-grained varieties of quartz. The common varieties of quartz are chalcedony, jasper, chert, flint, and petrified wood. Uses of quartz. Quartz is a major constituent in glass, like in microscope and telescope lenses. It is commonly used in jewelry. It is also used in citrine. Citrine, which is a charm that represents a healthy mind and body as well as happiness and success. It is used in making arrowhead, spear points, and other sharp tools. It is also used in concrete, mortar, and building stone. Quartz is a good auxiliator for watches or clock. Quartz watches keep good time because a quartz crystal, when hooked to a battery, vibrates at a constant rate. There are many uses of quartz because it can conduct electricity under pressure. It has heat resistance that make it valuable in electronic products. Because quartz is resistant to weathering, it is often one of the last mineral to dissolve. Last but not the least, muscovite, a common mineral of the mica family. It is commonly called potash mica or isinglass. Muscovite is not especially resistant to chemical weathering. It is quickly transformed into clay minerals. Muscovite is also an important rock-forming minerals present in igneous, metamorphic, and sedimentary rocks. Muscovite contains potassium and aluminum. Some properties of muscovite are: muscovite sheets have a pearly to vitreous luster on their surface. It has a Mohs scale hardness of 2 to 2.5 that makes a muscovite lightweight and somehow fragile. Muscovite also has a perfect cleavage that allows to split into thin, flexible, elastic, colorless, transparent sheets with a pearly to vitreous luster. If muscovite held up to the light, they are transparent and nearly colorless, but most have a slight brown, yellow, green, or rose color tint. Muscovite used in several ways and things. Sheet muscovite is an excellent insulator, and that makes it suitable for manufacturing specialized parts for electrical equipment. Scrap, flake, and ground muscovite are used as fillers and extenders in a variety of paints, surface treatments, and manufactured products. It is also used in making drilling mud, plastics, rubber, asphalt roofing, and some cosmetics. The pearlescent luster of muscovite makes it an important ingredient that adds glitter to paint, ceramic glaze, and cosmetics. Muscovite is not especially resistant to chemical weathering. It is quickly transformed into clay minerals. Tiny flakes muscovite sometimes survive long enough to be incorporated into sediments and immature sediments rock. And since muscovite has lower scale of hardness that makes it lightweight and fragile, it is not as stronger as the other light-colored silicate minerals and have not been subjected to severe weathering.
Alteration minerals. The word alteration means the action or process of transforming or being transformed. It is referred as alteration. Alteration of minerals, meaning the transformation of minerals. It can be through direct deposition, mineral replacement, or through leaching. Direct deposition is removing something, while leaching is the loss or extraction of a certain materials from a carrier into a liquid. The alteration of minerals is very dependent to its temperature. Why? Because we know the higher the temperature, the faster the movement of the molecules, and the lower the temperature, the slower the movement of the molecules. So the following list is some of the most important alteration minerals which we can found in geothermal fields. First, we got the serpentine. It is formed during hydrothermal metamorphosis of peridotite, dunite, and other ultramafic rocks. Hydrothermal metamorphosis occurs when very hot water reacts with rock and alters its chemical and mineral composition. So, serpentine cannot be found on Earth's surface. It is uncommon on Earth's surface, but abundant on the oceanic moho. Oceanic moho is the boundary between the oceanic crust and the upper mantle. Serpentine is not the name of a single mineral. Instead, it is a generic term for a large group of minerals, wherein for this X value, it can be magnesium, iron, nickel, aluminum, zinc, or manganese. And for Y, it can be silicon, aluminum, and iron. Next one is the chlorite. Chlorite is a dark green mineral consisting of a basic hydrated aluminosilicate of magnesium and iron. It forms by the alteration of mafic materials. It can also occur as a result of a hydrothermal alteration of any rock type, where recrystallization of clay minerals or alteration of mafic minerals produces chlorite. Next, we have clay minerals. Clay minerals are layer silicates formed as a result of the chemical weathering of other silicate minerals at the Earth's surface. They are most commonly found in shales. Shales is the most common sedimentary rock type. It is mainly used in industrial applications such as paper, paint, petroleum, ceramic, cement, adhesive, and even on the asphalt. The following groups are represented by clay minerals. First is the kaolin. Kaolin is a layered silicate mineral. Its basic structural unit consists of alumina sheet and silica sheet. Its thickness is 7.2 angstrom. Take note that 1 angstrom is equivalent to 0.1 nanometer. We use angstrom if we are measuring a very small distances. It is electrically neutral. That is why it is widely used in ceramic industry. It also used in medicine, coated paper, as a food additive, or even in toothpaste. Next, we have the illite. It is a group of closely related non-expanding clay minerals. It is very similar to Mount Morillonite. Its thickness is 9.6 angstrom. The connection between different structural units via a non-exchangeable potassium ion. There are many fields where lithic clays plays an important role. One of these is for the traditional ceramic for the production of cooking pots, plates, tiles, and bricks. Illite expands less than Mount Morillonite but more than Kaolinite. Lastly, we have the Mount Morillonite. It is the main composition of clay minerals in sediment and suspended particulate matter. An alumina sheet is sandwiched between two silica sheets to form a structural unit. Its thickness is 10 angstrom. It plays an important role for the food additive for health and stamina. It can also use in antibacterial activity against tooth and gum decay. This is the diagram of clay structure of the three clay minerals that we have tackled. We have the kaolin, illite, and Mount Morillonite.
May Almonguera, and I will be reporting the first part of non-silicate minerals, which is the metallic ore minerals. So earlier, my classmates explained what silicate minerals are. On the other hand, what is non-silicate minerals? Non-silicate minerals, all rocks are composed of one or more minerals. In order to be able to identify rocks, you have to be able to recognize the key minerals that makes up the rock. Non-silicate minerals are minerals that may contain either silicon or oxygen, but not both, as well as containing other elements. So, non-silicates are those minerals that doesn't contain silicate. As easy as that. Non-silicates can still, as said here, contains either silicon or oxygen, but not both, because containing both of them will be technically making it as a silicate minerals. So, A, metallic ore minerals. Ore is a natural occurrence of rock or sediments which contains enough minerals with economically important elements, typically metals. Metallic ore minerals are those that includes one or more metals, as the name implies. For example, sulfides, oxides, and such. So next slide. These are the examples of metallic ore minerals: the pyrite, the magnetite, and hematite. So metallic ore minerals, pyrite. One of the most common sulfide known as the fool's gold. It is part of sulfide minerals. Sulfide minerals are a group of inorganic compounds that contains sulfur and other elements. It is called fool's gold because it greatly resembles gold, while both pyrite and gold has a brassy metallic yellowish color. Pyrite is brittle, unlike the bendable gold. Pyrite is also used for making inks, for water treatments, moss killer, and many more. Magnetite, generally silver or black, it is the only strongly magnetic mineral which aids the identification considerably. Magnetite may have metallic silver color and may be dull to bright red, but in either case has a red streak. So magnetite generally seen with silvery and black hue, and might be also seen with red streaks. Magnetite is part of the inorganic group oxide minerals.
Magnetite is the only strongly magnetic minerals, which makes it easy to be identified. Magnetite is also used as an important iron ore for steel manufacturing, making pigments for paints and ceramics. C. Hematite. It's hematite. It is a dense and inexpensive mineral. Hematite is a major source of iron that is used to produce steel. Hematite with the E is also a part of the oxide minerals like magnetite, which means it contains oxygen. It is a dense and inexpensive material commonly used to produce steel because it is the main iron ore in the world. So that's all. Thank you.
Good day, everyone. I'm Roland Charles S. Baldassar for your reporter for today for this topic. So let's move on. Non-silicate minerals. Minerals without the presence of silicon, Si, or oxygen as, as a tetrahedral structure are what we call non-silicate minerals. Non-silicate minerals are divided to six just which are oxide, sulfate, carbonate, sulfate, halides, and phosphate. Is there a lot of non-silicate minerals? As silicate form more than 90% of the Earth's crust, there are not as much as non-silicate minerals compared to silicate minerals. And non-metallic minerals are naturally occurring inorganic substances found in a variety of geological environments and under varying conditions. It is a class of chemical elements that, when melted, produce no new products. Its reserve include quarries of stone and clay and sand pits, salt deposits, quartz, quartz deposits, gypsum, natural gemstone, asphalt and bitumen, peat, and other non-metallic minerals other than coal and oil. So, these are the six samples of non-silicate minerals. We have the oxide, a binary compound of oxygen and other element. Next is halides, a binary compound of a halogen with another element or group. We have the sulfide, a binary compound of sulfur with another element of group. Next is carbonites, a salt of carbonic acid characterized by the presence of the carbonide ion. Next is the sulfate or sulfide, a salt that forms when sulfuric acid reacts with another chemical. Last one is the phosphates, an element that provides a quartz of all the nutrients that plants need for their growth and development. Are there any uses for non-silicate mineral? Many non-silicate minerals are economically important and provide metallic resources such as copper, lead, and iron. They also include valuable non-metallic products such as construction materials and fertilizer. So we have example mineral in a non-metallic mineral we call calcite. A metallic a mineral that forms rocks and has the chemical formula CaCO3. It is extremely common and can be found in sedimentary metamorphic and igneous rocks all over the world. And calcite is the main component of limestone and marble. What are the uses of calcite? We have the construction. The construction industry is the primary consumer of calcite in the form of limestone and marble. This rock has been used as dimension stone in a mortar for thousands of years. Many pyramids in Egypt and Latin America were constructed with limestone blocks as the primary building material. Calcite in the form of limestone and marble is used modern constructions to make cement and concrete. These materials are easily mixed, transported, and placed as a slurry, which hardens into a durable construction material. Concrete Concrete is used in the construction of buildings, highways, bridges, walls, and variety of other structures. Next is used in acid neutralization. For hundreds of years, limestone and marbles have been crushed and spread on fields as an acid neutralizing soil treatment. In other information, in medicine, calcium carbonate derives from high purity limestone or marble is used. Calcium carbonate is mixed with sugar and fluoride to make chewable tablets that are used to neutralize stomach acids. It is also found in varieties of medications used to treat digestive and other ailments. In the chemical industry, calcite is used as acid neutralizer. Next, uh, in other information, the uh, calcite is what's the most widely used in mineral due, due to its properties. It is used in construction, herbicides, agricultural soil treatment, construction aggregate, pigments, pharma- pharmaceuticals, pharmaceuticals, and other application. Next, move on, we have gypsum, an everite, an everite mineral that is most found in layered sedimentary deposit with halite, anhydrite sulfate, calcite, and dolomite. Anhydrite is very similar to gypsum. The chemical difference is that gypsum contains two waters where areas anhydrite does not. The uses of gypsum is used to make wallboard, cement, plastic, plaster of Paris, soil conditioning, and as a hardening retarder in Portland cement. Gypsum varieties known as satin spar and alabster are used for a variety of ornamental purposes. Gypsum has several varieties named that are widely used in the mineral trades. We have the selenite. It's the colorless and transparent varieties that shows a pearl-like luster and has been described as having a moon-like glow. Gypsum has several varieties named that are widely used in the mineral trade. We have the selenite. It's the colorless and transparent variety that shows a pearl-like luster and has been described as having a moon-like glow. Another variety is a compact fibrous aggregate called satin spar. This variety has a very satin-like look that gives a play of light up and down the fibrous crystals. Another is a fine-grained massive material is called alabaster or alabaster, and is an ornamental stone used in fine carvings for centuries, even eons. Next, we have this halite or rock salt, the mineral name for the substance that everyone knows as salt. Its chemical name is sodium chloride, and a rock composed primarily of halite is known as rock salt. How does halite form? Halite is primarily a sedimentary mineral that forms in arid environments where ocean water evaporates. How is halite used? These are numerous applications for salt. Most of the salt produced is crushed and used on roads in the winter to control the accumulation of snow and ice. Salt is an essential nutrient for human and most animals, as well as a popular seasoning for a variety of foods. Chemical composition and physical properties of salt. Halite is the mineral that make up rock salt. Sodium chloride or NaCl is the mineral halite. Halite are rock salt. Geologic samples are typically white to clear in the color. Chemical composition and physical properties of salt. Halite is the mineral that makes up rock salt. Sodium chloride or NaCl is the mineral halite. Halite and rock salt geologic samples are typically white to clear in color but can also be blue, pink, yellow, red, and purple. Halite has a Mohs hardness of 2.5 on a scale of 1 to 10, indicating that it's a very soft mineral with the same hardness as your fingernail. Next, we have the barite. Barite, as also known as barite, as also known as barite, or barites is a mineral composed of barium sulfate. Barite is a white or colorless mineral that is the primary source of the element barium. Where is barite mostly found? Mostly barite is mined from layers of sedimentary rocks which form when barite precipitated onto the bottom of the ocean floors. What are the use of barite? Barite is the primary ore of barium, which is used to make a wide variety of barium compounds. Barite can block X-ray and gamma ray emissions. Barite is used to make high-density concrete to block X-ray emission in hospitals, power plants, and laboratories. And okay, that's all for now, everyone. Thank you for listening, and I hope you learned something for this lesson. Bye.